Hi everyone, Miss Brocker here. We're going to start getting away from working on mean, median, mode, and range, and we're going to start working on some fraction review from the school year. So today might feel very easy, and that is okay. A lot of this stuff is review from fourth grade, and a lot of the fraction stuff we did in fifth grade. We're going to work on some fractions and then some decimals over the next couple weeks. So today our learning target is to represent fractions in many ways. We're going to work on fractions of a whole, some fraction modeling to help us with that, fractions on a number line, and fractions of a set. Okay, first task. Using the fraction bar, we are going to represent 3/8 of one whole. Okay, now I just randomly drew a fraction bar here. This fraction bar, this gray rectangle you see, represents one whole. And what we want to do on here, what we want to see and make and create is 3/8 of that one whole. Remember when we talk about fractions, we're going to break our whole into 8 pieces. That is our denominator, 8 equal pieces. And then we have 3 of those 8 pieces, 3 of those 1/8 pieces. So the first thing I'm going to do is just use my marker and I'm going to partition or break this whole into 8 equal parts. Now, if you notice, I started with fourths. This is the easiest for me to do, and then I'm going to cut each one of those fourths in half, giving me 8 equal pieces. That means that this pieces were worth 1/8, and this piece is 1/8, and this piece is 1/8, and 1/8, and they're all 1/8. Okay. Now remember, we're going to try and represent what 3/8 is. So I'm just going to use yellow here, and we're going to shade in 1, 2, 3/8. That's all we're doing for the first part of this. Okay, next we're going to represent 5/7 of one whole using the fraction model below. So you're going to notice, and I'm sure you noticed when we did this in our classroom, that some fractions are very easy to partition and other ones, especially odd numbers, seem to be a little bit trickier. So I'm going to try this. Remember, when you do fraction modeling, it does not have to be perfect. As long as you know what should be represented, it's okay if your fractional pieces are not exactly how they should be. Okay, actually, I think that looks pretty good. I can see this last section right here is a little bit bigger than the first one, but that's okay. Each one of these represents 1/7. And I'm not going to go through and label these, but I know that I have 5 1/7. So we are going to shade in 1, 2, 3, 4, 5 sevenths, leaving 2 sevenths unshaded. And that's it. Okay, we're going to kind of do the same thing here, but a little bit different way to represent and show fractions. This is going to be fractions on a number line. And when I said this is going to be very much the same or similar as what we just did, now this number line or this straight line that I drew on the screen is going to represent our one whole. So we're going to first start by representing 5/9 and 2/3 on this number line. The first step is to partition your number line just like you would if you were doing one whole. Okay, so I'm going to use my red marker for that. Okay. Now, you might say, Miss Parker, you didn't draw ninths on there, and you're right. I started with thirds. And I started with thirds because for me, it is going to be easier to break those thirds into thirds again to create ninths than for me to draw 8 equal lines to create my ninths. Okay. Now, the other thing I would recommend you do when you were doing this, instead of just counting 1/9, 2/9, 3/9, 4/9, 5/9, and then labeling that, is to right away when you partition your whole or your number line to go ahead and put in some of those benchmark fractions with ninths. There's not that many of them. We could even do our equivalent fractions with thirds. So 0/9. I know this is 1/9, 2/9, 3/9, 4, 5, 6/9, and then this last one here would be 9/9. Okay. Now, if you want to fill in more than that, that is totally okay. If you want to put in 5, 4, 7, 8/9, that's also okay. I'm going to use my yellow marker to label 5/9, which is right here. And then I'm going to use blue to find my 2/3. And you might be thinking, Miss Barker, you did not partition this into thirds. And if you remember back, just slide your cursor back on YouTube a little bit, and you will see that I first started with thirds. But here it is right here. Because 6/9 and 2/3 are equivalent fractions. Or you could think about this being 0/3, 1/3, 2/3, and 3/3 at one whole right there. Okay, we're going to do the same thing down here, and we're going to represent 6/8 on our number line. So again, the first step is to partition your whole, and you can do that whatever way you want. I am going to start by doing 1/2, because I know that is 4/8. I'm going to break each one of those halves into halves, creating fourths, and then in half again to create my eighths. So this is 8/8 or 1 whole. Over here on the other end of the number line is 0/8. Okay. And now I'm going to go through and just label a couple of these. Let's do 2/8 here. I know that 1/2 is equal to 4/8. And then I'm going to do 6/8 here. If you want to label them all, that's okay. If you don't want to, you do not have to. Okay, now it should be pretty easy for me to place 6/8 on our number line, which is right here. Okay, this is our last piece of our learning target for today, and I would say that this is definitely the most difficult part and the part that I saw a lot of fifth graders struggle with this year. So it's good that we have time to do some extra practice on this. We are going to find fractions of a set, or I wrote AKA, also known as fractions of a whole number. Okay, so we did this a whole lot in our fractions unit, but I noticed even on our post-assessment that a lot of us still really struggled with this. So let's do these 4, and then there's one kind of picture problem we're going to do together too. Okay, so if you can think about this, and we might even draw a fraction model to help us with this first one, what we are going to do is break this whole number 18 into 3 equal pieces, and we are going to count one of those pieces. Now, when I say break that number 18 into 3 equal pieces, hopefully you are thinking about the operation of division. Now I'm going to draw a real quick fraction bar to help us out. Instead of this fraction bar equaling 1 whole, our fraction bar actually equals 18. And we're going to break that into 3 pieces. So I'm going to just partition that into thirds. Now think about if you have 18 and you're going to break 18 into 3 equal pieces, what does that mean each piece is worth? Or how many is each one of those thirds worth? And hopefully you're thinking, well, Miss Brocker, I know that 18 divided by 3 equals 6, and you're right. And because we have one of those pieces, then our answer here is just going to be 6. 1/3 of 18 is 6. 18 divided by 3 is 6, times 1, because we have one piece, is 6. Okay, now we're going to do that same thing down here, except for now we have 2/3 of 18. So I'm going to recreate that fraction bar real quick. See how fast it is to draw these fraction models to help your brain understand fractions? They're pretty hard to see and imagine a lot of times. So even just doing this little rectangle can be super helpful. Again, our whole is 18, so I'm going to write 18 up here. This whole fraction bar stands for 18. And think about, look at our denominator. How many pieces are we going to break that into? We're going to break that into 3 equal pieces. Okay? Now think, if you're breaking 18 into 3 equal pieces, you know that one piece is 6, and then this piece is also 6, and this piece is 6. So if you have 2 of those pieces, or 2/3 of 18, how much do you have? And I see that 6 plus 6 is 12. Now we aren't going to always want to draw a fraction model to help us do this, especially when we get to some of these bigger numbers. So let's think about the math that's really happening here when we talk through that, okay? Now what is actually happening is we are taking this number 18 and we are dividing 18 by our denominator. So 18 divided by 3 equals 6. Now, then we're going to look at our numerator and say, how many of those 1/3 pieces that equal 6 do we have? And we have 2 of them. So we would do 6 times 2 equals 12. And that's how we get our 12 without thinking about the fraction model. Okay, next 2 we're going to do without fraction modeling. So next one, 6/10 of 30. So what we're going to be doing is breaking 30, our whole number, up into 10 equal pieces, which is division. 30 divided by 10 is 3. So that's like if we were to build a fraction bar over here and we found one piece was equal to 3, then look at your numerator. How many of those pieces do we have? And that's what you're going to multiply. 3 times 6 equals 18. So 6/10 of 30 is 18. Okay, last one. 5/8 of 48. So instead of drawing our fraction bar, and we actually could draw a fraction bar really quick. It's super fast to do this. 48 is our total. And we're going to be breaking that into 8 equal pieces. Look at how fast that was. Now think about if you are just trying to find one of these pieces first. That's step 1. You're going to divide 48 by 8. And that equals 6. So if each one of these pieces is 6, and we have, let's see, we have 5 of them. I'm saying that because I'm looking at my numerator. You have 6, 6, 6, 6, 6. So instead of doing this repeated addition, I would much rather multiply 6 times 5 equals 30. So 5/8 of 48 equals 30. Okay, this is the very last one, and I know the top words are a little bit difficult to read, so I'm just going to read them out loud. We are going to circle 2/9 of the set. So this is actually the same thing we were just doing, finding 2/9 of a whole number, except for we don't have that whole number out in front of us. So we're going to have to figure that out. Looking at this kind of array that is here. So I'm going to use multiplication to help me with this. I see that there are, I'm just going to count this top kind of row, 2, 4, 6, 8 in each row. And I see that we have 4 rows of 8 plus 4. So 8 times 4 is 32 plus 4 equals 36. So what we're finding is 2/9 of 36. Okay. Okay. Now what we could do is a couple different things. First of all, we could draw a fraction bar to help us think about this. Otherwise, we can just use multiplication and division using our fraction knowledge. That's what we're going to do instead. So the first thing we need to do is find out what 1/9 of 36 is. And the way that we do that is by breaking 36 into 9 equal pieces. 36 divided by 9 equals 4. And then look at our original numerator, 2. We have 2 of those pieces, those 1/9 pieces, 2/9. So I'm going to multiply 4 times 2, and our answer is 8. So really, what we're going to do is circle one whole row. And it wouldn't matter which way you circle this. You could pick 8 random dots to circle as long as you have 8. So 2/9 of 36 is equal to 8. And we know that because 1/9 of 36 is equal to 4, and we have 2/9.